Hello, ladies and gentlemen. It's my honor to be here to present my report to you. The title of my report is Design of High-Speed Doppler Spectroscopy Diagnostic System for High-Field Reserved Configuration Device. Our report is divided into the following parts. The first part is background. Huazhong University of Science and Technology has been designed a field-reserved configuration device, which named as HFRC. The schematic and the typical parameters of HFRC plasma are as follows. In HFRC device, the rotation instability determines the lifetime of plasma. Drafting velocity and ion temperature are key parameters of plasma performance. A high-speed Doppler spectroscopy diagnostic system is designed for HFRC device to study the rotational velocity, drafting velocity, and ion temperature of plasma. The second part is the requirements and challenge. Let's start with the design requirements. We choose oxygen for 278 nanometer as the observation spectral line. According to the parameter conditions of the device, we obtained the oxygen field radiation intensity at 100 electron volt. Then we investigated the range of plasma rotation velocity and the ion temperature on other FRC devices. We obtained the range of Doppler shift and Doppler broadening, which provided a reference for our design. So here we have the high throughput, high resolution, and high speed requirements. At the same time, we also have a challenge. For planar diffraction grating, high throughput and high resolution are trained against one another in spectrometer design. The third part is design of spectral diagnostic system. According to the above requirements and challenge, the design scheme is as follows. It is mainly composed of spectral system, dry dispersion amplification system, and detection system. We choose MacBook Model 2007 spectrometer. Its high root density, long focal length, and large aperture provides high resolution and high throughput. And use fast-time response photomultiplier tube array provides high speed. But the photomultiplier tube is difficult to use in a high-resolution spectrometers due to its large channel width and spacing. So we designed the rare dispersion amplification system and the fiber array to face this challenge. The layout of the dispersion amplification system is as follows. The rare dispersion amplification system is composed of the cylindrical plano convex lens, which includes 5 lenses. Lens 2 and lens 3 are used to dispersion imaging and to realize dispersion magnification. Lens 1 is used to contraction of the light path and limit the image height. Lens 4 and lens 5 are used to vertical imaging, improve imaging quality, and reduce aberration. Here is the design result. We can find from the entrance image and the exit image full field spot diagram. The dry dispersion amplification system can realize 6 times magnification in the dispersion direction, without obvious magnification in the perpendicular direction. Finally, it is coupled to the chain width of the detector by fiber bundle. The left side connected with the dispersion amplification system and closed arranged. The right side connected with photomultiplier tube array and scaled arranged. We use 800 core fiber bundle with a core diameter of 200 micrometer. The fourth part is the system performance assessment. It is mainly include the form flux evaluation and the detector output signal intensity simulation. The form flux formula is as follows, and E expressed intended. It means array of plasma element radiation received by the detector. First, we obtained from the Fletcher database that the Oxygen 5 ratio varies with electron temperature as shown in figure. First, we get its radiation intensity and the phone flux. The range of the shade rays in the figure provides reference for our next assessment. For spectral system, our optical signal passes the detector becomes current, and by the transmittance simplifiers become voltage. Next, we combine the Doppler burden and voltage, obtain the Gaussian spectrum, shown in this figure. Finally, we do a discrete treatment of the Gaussian spectrum, and we obtain the detector of the signal intensity of each channel. Finally, here is the conclusion. A high-speed Doppler spectroscopy diagnostic system has been designed for fast field result configuration device to study the velocity of plasma. The system is designed to observe the light shape of oxygen-5 air emission by using a spectrometer. This dispersion amplification system and linear array multi-angle photomultiplier tube detector to realize high throughput, high resolution, and high speed. Phone flux affects detector selection. In these conditions, we can obtain one voltage signal intensity. For this design, spectral resolution, time resolution, and line dispersion all meet the requirements of experiment. That's all. Thank you for your attention.